Hi everyone. In this video, we're going to be talking about minerals. So let's get started. What are minerals anyway? Well, in the simplest sense of the term, minerals are the building blocks of rocks. Here's a rock. This is a piece of the igneous rock called granite. If you look carefully at this chunk of granite, you'll see all sorts of speckles of gray and white and black. And if you zoom in, you'll see that these are actually crystals, mineral crystals. This particular piece of granite has the mineral quartz, biotite mica, and plagioclase feldspar. We'll study these in more detail later on. So, on Earth, there are over 2,000 varieties of minerals, some of which are seen here. As you can tell, they come in a wide variety of colors, shapes, sizes, textures, and all sorts of different physical characteristics. Minerals have quite a few uses in our everyday life. Just to give you an example, this here is a rough, uncut diamond. Of course, we use diamonds for jewelry. We also use diamonds in construction applications, as the tips of saw blades, and a variety of other industrial uses. Here's another mineral. This is called fluorite, most famous for its inclusion in toothpaste. Yes, when you see the name fluoride on a toothpaste, that means it's made out of the mineral fluorite. But what else are minerals used for? Well, this here is talc. Talc is a very common mineral that is ground into a fine powder. It's very soft, and it's used in baby powder. Sometimes you might hear it referred to as talcum powder. One more example. This is a mineral selenite gypsum, which is used all around us in drywall. This is the material that's used to build the walls inside modern houses and buildings. But what exactly makes a mineral a mineral? Well, to be considered a mineral, the substance must meet 5 criteria. Let's go through those 5 criteria right now. Number 1, the substance must exist as a solid under normal conditions on Earth. This means if you have a liquid or a gas, under normal conditions, it cannot be considered a mineral. It must be in the solid state. Number 2, the substance must be naturally occurring on Earth. This means it cannot be man-made. So, for example, plastic is not considered a mineral because it doesn't exist naturally. It's created by humans. Must be naturally occurring. Number 3, the substance must be inorganic, meaning not coming from living or made of living things. So if you talk about, tree branches or leaves, they cannot be considered minerals because they are organic. That is, they came from living organisms. Another example would be coral. Coral is made by small sea creatures, and therefore it's organic material and cannot be considered a mineral. Minerals must be inorganic. Number 4, the substance must have a fixed chemical formula, meaning it's made up of a specific combination of elements. Let me give you an example. The mineral quartz is composed of silicon and oxygen bonded together, specifically 1 silicon bonded to 2 oxygen atoms. All quartz is made of this chemical formula. Another example, pyrite, often known as fool's gold, has a chemical formula of Fe, which is iron, and S, which is sulfur. And when these are bonded together in this particular arrangement, you get pyrite. So criteria 4 is that the substance must have a specific or fixed chemical formula. It has to be made of a specific recipe, if you will, of elements. And then finally, criteria number 5. The atoms that make up the substance must be arranged in an orderly crystal structure, a specific structure. Let me give you an example of this. The majority of the minerals that exist on Earth's surface are considered silicates, and that means they're made up of, in part, silicon and oxygen. The silica tetrahedra is the most common arrangement of silicon and oxygen atoms within a mineral. It looks something like this model here, where the red balls of clay represent oxygen atoms and the gray is a silicon atom. And you can see they're bound together in this tetrahedra shape, and this becomes the most common building block of minerals on Earth. So that's what we mean when we say the atoms must be made up of a specific orderly structure. I'll give you another example of that in just a minute. So let's test ourselves a little bit. Here are those 5 criteria. Must be solid, naturally occurring, inorganic, have a fixed chemical formula, and a specific atomic arrangement. So, what about this pool of liquid mercury? Can this be considered a mineral? Well, if you look at criteria number 1, it says it must be a solid, and this clearly is a liquid, so sorry Mercury, you're not a mineral. What about this chunk of bituminous coal? Well, if you know anything about coal, you would know that it's actually formed from ancient tropical plants that have been compressed and squeezed together for millions of years. So it is a solid, and it's certainly naturally occurring, but because it's made from plants, it is organic, and therefore it doesn't meet criteria number 3. And so coal is not considered a mineral. Well, what about ice? This is an interesting one. Let's go through our criteria. Is ice solid? Yes. And it does exist as a solid on at least some parts of the Earth, the poles specifically, and high up in mountains, you get water that exists naturally as a solid. So that's fine. Is it naturally occurring? Of course. There's quite a bit of ice naturally existing on Earth. It is not an organic material. It is not living. It never was living, and is not made by living things. It does have a fixed chemical formula, H2O, and it does have a specific atomic arrangement. So is it a mineral? Well, according to our criteria, yes, it is. However, there's a lot of debate about this, and some people think ice should not be considered it because most places on Earth it would exist as a liquid. So we'll give that one a question mark. What about this substance? This is sulfur. As you can see, sulfur exists as a solid. That's good. It's naturally occurring. It forms along volcanoes. It is inorganic. It's not living, and it never was living. It has a specific chemical formula. It's composed of the element sulfur. And it has a very specific atomic arrangement. If we could zoom in, we would see the atoms arranged in a specific way. So, for our criteria to be met, sulfur works. So, it is considered a mineral. Now, let's move on. I want you to keep in mind that all of the physical properties of a mineral, and what I mean by that is the colors, the shapes, the textures, the smells and the tastes, the appearance, the hardness, the sheen, all of these physical characteristics of minerals result from one specific thing, and that is the internal arrangement of the atoms. To give you an example, that sulfur we were just looking at is yellow. The reason it appears yellow is because of how these sulfur atoms are arranged inside. Quartz sometimes appear clear, and that's because of how the atoms are arranged. The mineral halite tastes salty because of how the atoms are arranged. The mineral sulfur, again, has kind of a rotten egg smell, and that's a result of the internal arrangement of atoms. So all of the physical properties result from how those atoms are arranged. Let me give you one really neat example of this. This is a diamond, the hardest mineral that exists on Earth. Fairly rare in nice, complete crystals. It is the hardest substance. It has a hardness of 10 on something called the Mohs hardness scale, which we will learn about. Now, diamond is composed of one element, and that is carbon. If you could zoom down inside this diamond, you would see the carbon atoms arranged in a pattern like this. Notice how all the atoms are interlocking, connected to one another. This creates a really strong bond, which is what makes diamond such a hard mineral. But let's look at a different mineral. Did you ever wonder what made a pencil write? Well, a lot of people have the misconception that it's lead. It's actually not lead. It's a mineral known as graphite. Interestingly enough, graphite, like diamond, is made up of only carbon. But if you look at how the carbon atoms are arranged, they're arranged into these sheets, which are not very well connected. The result is that though it's made of the same elements as diamond, it's a much, much softer, weaker mineral. So again, what gives these minerals their physical characteristics is how the atoms are arranged inside. So let's do a quick recap. First thing we talked about was how minerals are the building blocks of rocks. how they have lots and lots of uses on Earth. To be considered a mineral, it must meet our 5 criteria. It must be a solid, it must be naturally occurring, it must be inorganic, it must have a specific composition, and finally, it must have a definite structure. Thanks for listening.